Hello students, welcome to the chapter Aldehydes, Ketones and Carboxylic acids. In the previous video lecture, you learned oxidation and reduction of aldehydes and ketones. In today's video lecture, you are going to learn reactions due to alpha hydrogen atom, aldol condensation reaction, cross aldol condensation and Cannizzaro reaction. Dear students, these are the three very important reactions of the chapter which are asked for 2 to 3 marks in your board exam. And these three reactions are possible if there is a presence of alpha hydrogen atom with aldehyde or ketone. Let us begin our today's session. The first thing we are going to learn is acidity of alpha hydrogen atom of aldehydes and ketone. What is this alpha hydrogen atom? Dear students, it is a hydrogen atom which is attached to carbon atom adjacent to carbonyl carbon in aldehydes and ketones. We have an example here, CH3 C double bond O CH3. The carbon atoms which are linked to carbonyl carbon are alpha carbon atom, and the hydrogen atoms which are present on those alpha carbon atom, they all are known as alpha hydrogen atoms. That means there are total 6 alpha hydrogen atoms. These alpha hydrogen atoms are acidic in nature due to strong electron withdrawing effect of carbonyl group of aldehyde and ketone, and which is resonance stabilized by its conjugate base. That means we have carbonyl group to which there is a presence of carbon atom and which is known as alpha carbon atom, and the hydrogen atoms present on that alpha carbon atom are alpha hydrogen atoms. It means there is a presence of one alpha hydrogen atom now, which is attacked by base. The base is going to withdraw the hydrogen atom. In turn, the hydrogen atom donates its electron to alpha carbon atom. That leads to the formation of an conjugate base where negative charge is present on alpha carbon atom. The oxygen atom of carbonyl group being more electronegative, it withdraws bonded pair of electrons of carbonyl group. Hence, it gives a resonance stabilized structure. Now, in the second case, there is a negative charge present on oxygen atom. And these two structures are conjugate base and both are resonance stabilized. Let us learn aldol condensation now. The aldehydes and ketones having at least one alpha hydrogen atom can undergo the reaction with dilute alkali to form beta hydroxyaldehyde, which is also known as aldol, or beta hydroxyketone, which is also known as ketol respectively. And this reaction is known as aldol reaction. Example, the 2 moles of acetaldehyde, when they are treated with dilute NaOH, 2 moles CH3 C double bond OH, CH3 C double bond OH. The 2 moles of acetaldehyde, it is treated with dilute NaOH. There is a transfer of electrons of alpha hydrogen atom to alpha carbon atom in one of the molecule. Hydrogen atom goes without the electrons, gets positive charge. The carbon atom which gain the electron gets the negative charge. Now the negatively charged carbon atom is going to attack the carbonyl carbon of another acetaldehyde molecule. In turn, the oxygen atom of that molecule withdraws its shared pair of electron towards itself. Now the oxygen atom gets a negative charge. The hydrogen atom which is liberated as H+, it is going to attack negatively charged oxygen atom. Let us learn this process once again. The hydrogen atom of alpha carbon atom is donating its electron to carbon. The carbon atom is going to attack the carbonyl carbon of another molecule. In turn, the oxygen atom withdraws the electron. Now oxygen is negatively charged, which is satisfied by positively charged hydrogen atom, which is liberated at the beginning of the process. and this process leads to the formation of a compound aldol. It is 3-hydroxybutanol. Aldol because there is a presence of aldehydic functional group as well as alcoholic functional group. Further, this aldol which is heated, which loses a molecule of water, the hydrogen atom of alpha carbon atom and hydroxyl group of beta carbon atom leads to the formation of alpha beta unsaturation or alpha beta double bond, and which is known as alpha beta unsaturated carbonyl compound. The aldol and ketones which are formed in such reaction, they lose water molecule on heating to give alpha beta unsaturated carbonyl compounds, which are aldol condensation products, and the reaction is known as aldol condensation. So the water molecule is going to liberate, it is from the hydrogen atom of alpha carbon atom and hydroxyl group of beta carbon atom. So let us see the process. After heating, the hydrogen atom is going to donate its pair of electrons to carbon-carbon bonding. In turn, the OH group is going to come out as OH minus. OH minus and H plus water molecule is liberated, and the final product alpha beta unsaturated carbonyl compound is formed, and which is known as aldol condensation product. Moving further, this aldol condensation can also be catalyzed by other bases like barium hydroxide, BaOH twice. So we take 2 moles of acetone which is treated with barium hydroxide. The same process is going to take place in ketones also. That is, the hydrogen atom is going to donate its electrons to carbon atom. In turn, the carbon atom is going to attack the carbonyl carbon of another molecule. Oxygen gains the electrons, and oxygen is going to attack hydrogen atom which is liberated at the beginning of the process. That leads to the formation of ketol, because the starting compound we have taken, it is a ketone. The ketol name is 4-hydroxy-4-methyl pentane 2-one, which on heating liberates water molecule, hydrogen atom of alpha carbon atom and hydroxyl group of beta carbon atom, leads to the formation of a final aldol condensation product, that is alpha beta unsaturated carbonyl compound. The name of the compound is 4-methyl pent 3-ene 2-one. Dear students, please remember, the name aldol is derived from the names of 2 functional groups, aldehyde and alcohol. Even though ketones give ketol, the general name aldol condensation is still applies to the reaction of ketones due to their similarity in reaction with aldehydes. The aldehydes and ketones with minimum 1 alpha hydrogen atom can undergo this type of reaction. Moving to the next part of video, it is cross aldol condensation. Dear students, please remember, in simple aldol condensation we have taken the reagents of same molecular formula, whereas in cross aldol condensation we are going to take 2 different aldehydes or 2 different ketones or a mixture of aldehyde and ketone. When aldol condensation is carried out between 2 different aldehydes or 2 different ketones or a mixture of aldehyde and ketone, is known as cross aldol condensation. If both the reactants contain alpha hydrogen atoms, then it is going to give mixture of total 4 different products. Let us learn the reaction. Example, ethanol that reacts with propanol in presence of base like NaOH, followed by heating, liberates 2 different products. If the reaction is taken place between the molecules of ethanol only, we are going to get the product but2-enol. If the reaction is going to take place only for propanol molecules, then it is going to give the product 2-methyl pent 2-enol. So the first product formed if the two molecules are ethanol, and the second product is formed if the two molecules which are reacting, they are propanol. And such type of reaction is known as simple or self-aldol products. If the reaction is taken place between two different aldehydes, that is ethanol and propanol, internal reaction, if it takes place in presence of NaOH followed by heating, gives two more product, 2-methyl but 2-enol and pent 2-enol. And these two products are formed when one molecule of ethanol and one molecule of propanol reacts in presence of NaOH, and this reaction is known as cross aldol reaction, and the products are cross aldol products. Moving further, ketones can be used as one of the component in a cross aldol reaction. For example, benzaldehyde that reacts with acetophenone in presence of a base which is heated at the temperature 293 Kelvin liberates water molecule, forms alpha beta unsaturated carbonyl compound, and the name of the compound is 1,3-diphenyl prop 2-en-1-one, which is also known as benzyl acetophenone, and which is the major product formed. Moving to the next part of video lecture, Cannizzarose reaction. Dear students, please remember the first two reactions, that is aldol condensation and cross aldol condensation, they take place only in the presence of minimum one alpha hydrogen atom. If there are no alpha hydrogen atoms with aldehydes or ketones, then such type of compounds in presence of base, they undergo Cannizzarose reaction. So in presence of alpha hydrogen atom, aldol condensation, cross aldol condensation. In the absence of alpha hydrogen atom, Cannizzarose reaction. Let us learn the reaction. The condition is aldehyde which do not have alpha hydrogen atom undergo self-redox reaction on heating with concentrated alkali. In this reaction, one molecule of aldehyde undergoes oxidation whereas another molecule undergoes reduction. The reduced molecule gives alcohol and oxidized molecule gives carboxylic acid. It means the products formed are salt of carboxylic acid and alcohol. Example, formaldehyde, where there are no alpha hydrogen atom, because the condition for alpha carbon alpha hydrogen atom is the carbon atom which is attached to carbonyl group is alpha carbon. As there are no carbon atoms attached to carbonyl group, there are no alpha carbon atoms and no alpha hydrogen atoms. One molecule of formaldehyde reacts with another molecule of same formaldehyde in presence of concentrated alkali, undergoes self-oxidation and reduction. The reduced molecule of formaldehyde gives alcohol, methanol, whereas oxidized molecule gives salt of carboxylic acid, it is sodium formate. Moving further, example, two molecule of benzaldehyde, as benzene ring is C6H6, one of the hydrogen atom is replaced by CHO group, and the carbon atom which is attached to CHO is alpha carbon, and which not have any alpha hydrogen atoms because it satisfied its valencies 1, 2, 3, 4. All the 4 valencies are satisfied. When benzaldehyde reacts with concentrated NaOH, it gives rise to the product benzyl alcohol and salt of benzoic acid, that is sodium benzoate. This is the commonly asked reaction in your board exam. Try to write the explanation. Benzaldehyde reacts with concentrated NaOH, undergo self-redox reaction, forms benzyl alcohol and sodium benzoate. This is the statement. Moving further, aldehydes which do not contain alpha hydrogen atom can undergo this type of reaction. Acetaldehyde, formula is CH3CHO, where there is a presence of alpha carbon atom and alpha hydrogen atom which can undergo aldol condensation and cross aldol condensation but not Cannizzaro reaction. Whereas benzaldehyde not contain alpha hydrogen atom can undergo Cannizzaro reaction. Benzaldehyde, it is a benzene ring C6H6. One of the hydrogen atom is replaced by CHO, and this CHO attached to the carbon atom where there are no other hydrogen atoms. Next one, ketones do not undergo Cannizzaro reaction as it contain alpha hydrogen atom. In this reaction, same aldehyde undergo both oxidation and reduction. This type of reaction in which same compound undergo self oxidation and self reduction is known as disproportion reaction. Thank you dear students. Hope you enjoy the session. Thank you very much.